Good morning, everyone. My name is Anut Sangka. Today, I will talk about my research in my PhD. In the topic of toward the viability of kappa H1 to point statistics. Okay. First, let me introduce the 21 centimeter cosmology, which actually the electromagnetic radiation by the spectrum of hydrogen hyperfine structure, which is the most abundant element in the intergalactic medium. When we talked about the neutral hydrogen, we 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 can separate its main sources to the main source to the two main sources. The first one is the remnants from the epoch of reionization, which range from around redshift 6 to redshift 10, roughly. And the second one is the neutral hydrogens in the hot star forming region in the low redshift galaxy, which is this research target. Okay. Well, instead of measure or identify the individual point sources of neutral hydrogen, it's easier to measure its density, like we map from the point source to the heat map, right? What I show in my slide. Okay, which is similar to the technique that we measure the cosmic microwave background radiation. When we measure the surface binary temperature of the H1 and try to find out what is temperature fluctuation, we can treat that fluctuation like the bias tracer to the over density matter delta in this equation. Okay, so by study this intensity map, we can tell how our local galaxy evolution. Okay, evolution. Then what happened if we measure the correlation between H1 and the image background source, which can deflect by the neutral hydrogen. So it's similar. In that regard, we can measure the two-part statistics between the lensing convergence and neutral hydrogens intensity mapped. So for the lensing effect, we have the diffraction angle, which can describe by this equation. From this equation, you can see in lensing kernel that you expect it have the long wavelength effect because it contains the co-moving distance to the image source chi s here. So when we measure the two-point correlation function, we can also measure the angular power spectra, which is the amplitude square of the spherical harmonic mode. From this equation, you can see that the couplings of neutral hydrogen bias and the long wavelength mode of lensing kernel. here. The problem of this statistics is because normally neutral hydrogen have lower signal compared to its foreground, which mostly is the galactic synchrotron radiation, which has 3 order of magnitude brighter than H1. But due to its characteristic, as you can see from the plot, that have the flat, quite have the flat spectrum for the foreground, we can apply the foreground removal technique by removing the radio long wavelength mode. Okay, but however, when you doing that technique, it would reduce the signal of H1 and lensing correlation. And another problem is because it's measure the intensity instead of identify the particular point source, it have the poor angular resolution. And for the H1 bias, we still don't know much about the H1 bias. So in order to study the 2-point statistics between these two cosmological fields, I used the Takashi et al. 2007 catalog, which based on 9-year W map. And then I select 35 realizations of that catalog from 107 realization. From that catalog, I track down the over density matter profile and use them to generate the surface brightness temperature of H1. Okay, and then measure the 2-point statistics, which even when we already apply the removal, the foreground removal technique, which could remove the signal between H1 and kappa correlation, we still can see the signal of such correlation, which is the red curve in the left side panel, as you can see here.
There's 2 minutes
and the
left.
right, sorry?
2 minutes left.
Okay. And the red line, can you see the red line? And the right hand side show the ratio between the average amplitude of unclean and clean signal. You can see that it reduced the signal by the flat ratio across the L mode, okay? Which is pretty cool because we can confirm that we can observe the correlation between lensing and neutral hydrogens, even though we remove the foreground by apply the long wavelength mode removal technique. Okay, and then from the result we can make the cosmological forecast by using the Fisher forecast, and here is the 2 sigma level of confidence. And when we apply the uncertainty for the forthcoming survey, in this case is the instrument noise and thermal noise for kids, death, and meerkat and GPT, and we separate the uh, cosmic variant and instrument noise. We can see that uh, the magnitudes of those noise are comparable to each other. Okay, and here is my conclusions. First, the forecast removal only merely affect cross correlation of H1 and lensing by the factor of occurring. Okay, and the correlation between the two reduce the degeneracy of cosmological parameter to the sufficient level, but we need multiple redshift. Okay, the linear evolution of H1 bias is effective enough to constrain the cosmological parameter. And the last one is when we consider the thermal and instrument uncertainties, the redshift bin size must be large enough to gain the signal to noise ratio. And thank you for your attention, and feel free to comment and ask me questions. Sorry for very thorough presentation.
Thank you very much.